Hello and welcome one and all. Today we'll continue with supervised machine learning algorithms. In the previous two videos we looked at classification. In today's session we'll look at linear regression. Regression is a statistical procedure that determines the equation of a straight line that best fits specific set of data. It predicts the outcome of a variable known as the dependent variable using an independent variable. For instance, predicting the price of a house based on the square feet of the house, or predicting the sale of a company based on its marketing budget. In this session, we'll briefly go over what linear regression is and how it can be implemented for a single variable, which is simple linear regression, for multiple variables, multiple linear regression. We will use sklearn, which is one of the most popular machine learning libraries for Python. The term linear refers to a proportional or a direct relationship between two or more variables. For example, if the value of x goes up, then we'll see a change in the value of y. Linear regression performs the task of predicting a dependent variable value, y, based on a given independent variable, x. So this regression technique finds out a linear relationship between x, the input, and y, the output, hence the name linear regression. If we plot the independent variable x, marketing budget in this case, on the x-axis, and the dependent variable y, actual sales, on the y-axis, the linear regression gives us a straight line that best fits the data point, as shown in the figure. We know the equation of a straight line. If you recall it from your school days, it is y equal mx plus b. Y in this equation is the dependent variable that we are trying to predict. In this case, it is the sale amount we are trying to predict. M in this equation is the slope of the regression line. It is the change in x and what impact it has on the y. X is the independent variable that we use as the input. In this example, it is the marketing budget, while b is the y-intercept. It is the value at which the fitted line crosses the y-axis. If we were to complete the regression line so that it crosses the y-axis, at the point where it crosses the y-axis is the y-intercept, or b. It is somewhere around 3.6 or so. So basically the linear regression algorithm gives us the best value for the y-intercept and the slope. The y and the x variable remain the same since they are the data features and cannot be changed. The values that we can control are the intercept and the slope. What the linear regression algorithm does is it fits the line on the data points and returns the line that results in the least residual error, meaning the less distance between the data point and the regression line. We will see how Python's scikit-learn library from machine learning can be used to implement the regression function. We will start with simple linear regression involving two variables, and then we will move towards linear regression involving multiple variables. Okay, enough talk. Let's dive into coding and see how we perform simple linear regression. I have my Jupyter notebook open. At the top, I am importing the required libraries. Make sure you have these libraries installed prior to running this code. First of all, we have NumPy and Pandas. We will use Pandas to import and transform data, followed by Matplotlib and Seaborn. We'll use these libraries for visualization. And then we are importing sklearn, and from sklearn, we'll use the linear model to generate a regression model. Complete notebook along with a dataset is available on the GitHub. Link is in the description below. I am going to run this cell with keyboard shortcut Shift plus Enter, or you can select the cell and click the Run button from the toolbar menu. Let's go ahead and import our data. We are importing an Excel file with the help of Pandas read Excel method, and we are saving it to a data frame called df. let's go ahead and print the DF to get a sense of the data. It is a simple data set with two variables, marketing budget in thousands and actual sales in million. This data set has 17 observations or rows. Let's see the correlation between these two variables with a seaborne heat map. Marketing budget to itself has a correlation of 1, which is expected. But we are interested in actual sales and marketing budget relationship. These two variables share a strong relationship and it is pretty close to 1, 0.95 to be precise. So it is safe to assume that change in one variable will impact the other. For example, the increase in marketing budget will result in higher sales and a decrease will negatively impact the sales. Let's visualize these two variables on a scatter plot to gauge the relationship. To the scatter plot method from the matplotlib library, we are supplying the marketing budget and actual sales column. As the heat map suggests above, there's a strong correlation between these two variables. And we can see this in the scatter plot as well. As our marketing budget goes up, we see an increase in our sales numbers. So there's a positive correlation in these two variables. To prepare our data for the linear regression model, I will create a new data frame with just the marketing budget column. I am dropping the actual sales column from the data frame. This is our X or independent variable. For the dependent variable or Y, I am saving the actual sales column from the data frame to a sales variable. With X and Y ready, we can create a linear regression object by calling the linear regression from linear model. It is saved to a LR variable so we can use it later. Let's call the fit method from the LR and supply it X, which is the NDF data frame. It contains only one column, marketing budget, then the Y, which is the sales variable. Let's run the cell and our regression model is trained and ready. Now we can start making predictions with it. I will bring up the data set and get a budget value from here. Let's say we want to predict the sale for budget of 150,000. Back to our model, we provide the budget amount of 150K and it gives us 11 millions of predicted sales figure. It is slightly higher than the actual, but very close. The actual sales amount is 10 million for this budget amount. Let's go ahead and generate predicted amount for all the budget amount in our data set. We will call the predict method again, but this time we will provide it the new data frame. If you recall it, this data frame only consists of budget amount column. We are saving the predicted values to Y underscore predict variable. We can plot the predicted values on top of the scatter plot. So same as above, we are plotting the marketing budget and the sales amount. And on top of this, we are plotting a line with the marketing budget and the predicted sales values. Let's review the plot. The regression line is the predicted values by the model. It is the best fitted line to the data points on the plot with least distance from the data points or least residual error. We can obtain the y-intercept and the slope values from the linear regression model. We will call the intercept and the coefficient, and it prints out 3.352 as the value of the intercept and 0.052 as the value of the slope. With the help of these two, we can plot the regression line manually. Our linear equation is y equal mx plus b. For the linear equation, we need m, the slope, b, the intercept, and x, the independent variable. Let's recall the scatter plot again with budget and sales. But on the line plot, first we supply the marketing budget, and then let's put the equation values. So for m, we are providing 0.52 times x, marketing budget, plus b, which is the y-intercept, and the value for b is 3.352. So if we were to run this cell, it should give us the same regression line as above. The regression model calculates these values and then predicts the values based on these parameters. Now we are going to compare the model predictions against the actual values. For this, we can plot the actual sales line and then plot another line with the predicted values. The original values are in red and predicted values in blue. The model does a fairly good job of estimation. As we can see, the line curves are matching the actual sales and the predictions follows the similar pattern. However, there are a few deviations in few spots, especially at the end. Let's do a fun exercise and predict the sales for the forthcoming budget. For instance, let's assume we are coming up with a budget for the next few quarters. I have the budget amount in a dictionary with the key of marketing budget and list of budget amount values, which I am converting to a data frame for the ease of use. The aim is to predict sales amount for these budget values. We will call the lr.predict method and pass in our new data frame. Let's save the outcome in a variable called PS for predicted sale, and let's print this variable out. Once I run this cell, it prints out the predicted values. We can append this variable to our new data frame as a new column. Here we go. This is our forecasted budget amount along with the predicted sales amount. We can export this data frame to a flat file for further review or for our dashboards for actual versus forecasted analysis. And we can compare a few months down the road. We can test our predicted amount against the actual and see how the predicted values fare against the actual numbers. And we can repeat these steps to add new data and train our model to help it make better predictions. I hope you find this session useful. If you like the content, be sure to like and subscribe. Post any questions that you may have. Take care of yourself, and I'll see you in the next video.